Good morning. Right, we are going to continue with the series of drawing objects on the two-dimensional Cartesian plane. Right, we're going to focus on drawing straight lines today because they've got a very specific formula in algebra. We understand the Cartesian plane. We know this is the y-axis. It's positive in the up direction, negative in the down direction. This is the x-axis. It's negative towards the left of the origin, right? And it's positive to the right of the origin. Where the x and the y-axis cross, they cross at 90 degrees. And we have that little place called the origin, or let's just call it the point 0, 0, where both of them are 0. Right, let's continue. Okay, so all lines have got a very standard way of being represented, and they are y is equal to mx plus c. So when you draw a straight line, or the formula of a straight line, or in algebra where you've got two variables, a y and an x, you can always draw them as a line. In the case where it's a straight line, all right, x has always got to the power of 1, but let's cut that. Right, y is always equal to mx plus c. Straight lines, y is equal to mx plus c. That's something that if you don't know it already, you need to remember it. It needs to become part of your life. If you wake up in the middle of the night and you hear the word straight line, you must be able to say y is equal to mx plus c. Right? And when that happens, y represents the y values, x represents the x values, c, right, is where the line that you're drawing will cross the y-axis. Sometimes it doesn't. All right, but c will be where it crosses the y-axis. So if c is 0, you know it's not going to cross the y-axis, just by the way, right? M, right, this m before the x represents the inclination or the slopiness or the way that the line lies. And these concepts will become clear to you, right, in the course of this video. Okay, so when we draw points, we know that we want to represent them as x, y. So I've got two examples here where x is 3 and y is 4 is a point. Right, and that point will be represented as bracket 3 semicolon 4 close bracket. That's the way we represent a point. Okay, and similar 5, 9, the x value will be 5 and the y value will be 9. Okay, so let's start plotting some things. All right, we've got our pattern, y is equal to mx plus c. Let's take an example. We know what they represent, so let's say y equals 8x plus 1. How are we going to draw this? Well, we can't really draw a line, right, given a formula like this, unless we plot the points. So let's plot the points first. Okay, so we calculate the points and we plot them. Now, it's always a good idea. You start off with x is equal to 0 because it gives you a good reference point. I normally then go x minus 1 and x plus 1. And let's have a look at how that works. Right, but let's plug in 0, right, into x. So if x becomes 0, then y is equal to 8 times 0, which is 0, plus 1. So y will be equal to 1. Right, we've got our first point that we can plot. Okay, we can plot the next point, right, which will then take 1. I normally take 1, plug it in, right, 8 times 1 is 1, plus 1 is 9. So where x is equal to 1, y will be equal to 0. Plot it like that. And then I normally do a third one. It just helps you check your work accurately. You don't have to do a third one because you've got 2 points now. You can draw a straight line, right, and continue it past those points, but it's always a good idea to do 3. Trust me on this one, okay? And I normally just go to minus 1, right? So if we put minus 1 into the 8x over here, right, as the value of x, then you get 8 minus 8 plus 1, right, and you get minus 7. So these are 3 points we can use to draw the graph. Okay, so let's draw these points that we put together. The first one I'm going to draw is, let's draw the y values. So we draw the minus 9, the dotted line, and we draw the 9 with the dotted line on the y-axis. Those are the blues. So that along those axes, that's where we are. Okay, then we go ahead and we draw the corresponding x values. So where it's minus 7, the x value is minus 1. And where it is 9, the value is x. Okay. I'm going to leave this a little bit for you to look at very carefully. Right, I've slowed things down enormously. We've plotted those 2 points. Be very sure that you understand that's the 1 point and that's the other point. So the first point being 1, 9 and the second point being minus 1, minus 7. Great, now that we've done this, let's just draw a line. Okay, so I'm going to select a different color for the line over here and we'll draw the line. between those 2 points. Now we know that in the equation it goes beyond those 2 points, but for the sake of this video, we're just going to draw them to the points. Okay, right. Now, the first thing that we've got to have a very careful look at this line is once we've drawn this line, we've got a third point to check ourselves, and that's that point over there. And guess what? That point is 0, 1, and it is one of the points that we put together. Okay, so all three of our points line up in a line. We know we've drawn our line correctly. So if all three of the points line up, that's absolutely great. We know that we've done it correctly. Right, so now that we've drawn the graph, right, remember we rearranged these so they looked they're a little bit more intuitive for us to use. Let's evaluate some of the stuff that we've drawn in this graph. The format is y is equal to mx plus c. Y is equal to 8x plus 1. That's our example. This is what the line looks like. We've been through that. Okay, so let's evaluate C a little bit more. So what is C? What does C really, what does it really mean? What does C really mean in this equation? Quite simple. From the formula, in this case, we can see C is equal to 1, 100%. But, and on the graph, we can read it off and we can say, right, if we just take it for granted that this is where the purple line will cross the blue y-axis, right, will be 1, right? That's fine, okay? But why is this like this? This is quite an important question. It's very, very simple, right? If we take that point where x is 0, right? Then where x is 0, our formula will look like y equals 8 times 0 plus 1, y is equal to 1. So, very interesting. Remember that x is 0 all the way along the y-axis. Okay, so it stands to reason that where x is equal to 0, y is equal to c. So that is why we say that c is the y-intercept. And that's a little bit of a great moment for us to get to. We've proved to ourselves that where y is the place where x is equal to 0. Let me say that again. Where x is equal to 0, we have y equal to c, because the m is meaningless at that point in time, right? So that is the crossing point where the line that we've drawn crosses the y-axis. Okay, good. Now we plotted 8x plus 1, right? But that's the same as writing y is equal to 8 upon 1 on x. Just accept that for now. There's a reason why I'm going there. Because 8 wholes is 8, but we write it like that because we're trying to figure out what does m really mean. Remember, it's called the slopiness or the intersect, or how sloped is it? That is, it's not a straight, it's lying off to the right, it's starting in the bottom left and going to the top right. Let's figure that out. Right, so if we take those 2 points to start with, right, and we say, right, if we go along that line, right, from 1, right, 9 to 0, 1, then y goes from 1 to 9. So as this line goes along here, y goes from 1 to 9. At the same time as what y is going from 1 to 9, okay, x goes from 0, remember x is 0 here, to 1. Okay, have a careful look at that. So if we draw the line from that point that I'm indicating to that point, right, y goes from 1 to 9 and x goes from 0 to 1. So the change, and that's a delta, the change in y was 8 and the change in x was 1. And guess what? If that's a ratio, because that's what we're trying to get to, 8 upon 1, and hallelujah, that's the same. That is exactly the same. So that is the slope of the line. Now, this must hold true for the comparison of any two of these points. We've compared the first two, right? Let's compare the next two, right? So if we draw the line, okay, from 1 to minus 7, so we go, right, let's go from 1 on y to minus 7 down here, right? the line is going down. So as this goes from 1 to -7, x goes from 0 to -1. Look at it again. If we go from 1 to -7 on the y-axis, we go from 0 to -1. So if we go from 1 to -7, we've gone in the negative direction. So there's a decreasing here. Our change is delta -8. We've gone -8 down. At the same time, we've gone in the negative direction from here to here when we draw the line. Okay, and that's also in a negative direction. As this line goes down, the x is going negative, and the change is delta -1, right? So the change is the same as delta -1. And if we write those two on top of each other, the negatives become positive because they're both negative, 8 upon 1, and we're back to the same equation. Right. So let's carry on. We need to do the last 2 points just to prove things to ourselves. Remember, we're trying to sort out what the m means. Okay, so let's take those last 2 points. And in this case, we're going to go down the line as it goes down. All right. And when y changes from 9 to -7 at the bottom, right, we've had a change in the negative direction because we're going in the negative direction of -16. Right? At the same time, x goes from 1 to -1. Okay? So x goes from 1 to -1, and 9 goes from, y goes from 9 to -7. So y went from 9 to -7 was -16 in that direction. And at the same time, x went from 1 to -1, which was negative direction as well. Now, if we put those two and make a fraction out of them again, or a ratio, a fraction is nothing more than a ratio, we get -16 upon 2, which is 8 upon 1. And this is really, really interesting for us, right? So we now know that m represents how sloped the line is. Okay, we plotted that, right? M is the slope of the line, right, which we call the inclination in fancy terminology. How well is the line inclined? Inclined means to lean. Does the line lean to the left? Does it lean to the right? Okay, and how much does y, and we ask ourselves the question, how much does y change as x changes? Because that is the definition of slopiness or inclination. And wow, we understand that one too now. Great. Okay, so I've just put up some arbitrary graphs over here. Let's work with this. All right, I've indicated over here where we go. Let's get, now the question is different. We're given a graph and we're asked, what is the equation of the graph? We know the format is y is equal to mx plus c. So let's have a look. Right, first of all, let's look at m. X goes from 0 to -1. If we draw the line upwards, where x goes from 0 to 1, the corresponding makeup of a triangle, if you want to view it that way, that's a good way of viewing it, would be, right, y goes from 1 to 3. Okay, so m we now know as the change in y over the corresponding change in x. So you're going in the same direction, and this is -1 in the x, right, and 3. So it's -2, because 2 upon -1 is -2. So we know m is -2. Okay, that's the first part of the problem. C is the y-intercept, but that's very easy to calculate because we know that where a line crosses the y-axis, okay, x is 0. So we can just put 0 into here, right? So, and then c is equal to 1. Okay, we also can see that the y crosses the line there, and we can put it in. So the equation for this line is y is equal to -2x plus 1. Okay, let's look at one that's slightly more complex, right? And there are two things that I want to show you. The first thing that I want to show is this is the first graph that we're looking at that actually lies in this direction. Okay, and the second thing is that we've got halves as our blocks over here. So that's -1, -2, halves. Don't be confused if this gets asked you in an exam, right? Remember, we're dealing with m as a ratio. Okay, so let's get now the question is, once again, get an equation from the graph. We know that the format is y equals mx plus c, right? So m goes from a point 3, 1, 2, 3 little blocks, point 3. Don't call it 3, call it a point 3, okay? From 3 to 0 at the same time as what y goes from 0 to 2 blocks. Remember, we're talking blocks here, right? They happen to be half integers, but 1, 2, 3, and y goes from 0 to 2. Okay, very interesting. Okay, now we know that m is the change in y over the corresponding change in x. Okay, but 0 to 3 was in the negative direction, so that's very important. So it's a minus. Okay, minus 3. It went negative. It's not minus 3, it's negative direction. Okay, so let's just do that again. X goes from 3 blocks to 0 blocks, because we need to find a triangle that's easy to read. Let's just start there. We need to find a triangle that's easy to read. So X goes from 3 blocks to 0, right? At the same time, a corresponding change along the line is Y goes from 0 to 2. But because the X changed in the negative direction, it's a minus 2 upon 3. Okay, C is, and that's our M. Let's look at C. C we know is the y-intercept. Where does the graph cross the y-axis? It looks like it's minus 1. Okay, C is minus 1. All right, so very simple. Remember, where C is equal to, where y, along the y-axis, x is equal to 0. So that kind of goes away over there. So y is equal to c. C is equal to 1. So here, our formula for this line is y is equal to minus 2/3 of an x, or minus 2 upon 3x plus 1. And, wow, we can read, we're actually in a position where we can now read a graph and write down the formula. We can look at a graph formula and develop a graph. That was the object of this lesson. Thank you. Right, my channel is mathforyou.today. Right, it's a website. The website is nearing final completion. Go and have a look at it. You'll find this over there. Okay, if you like the video, subscribe it, stick on the bell. You'll get warnings if I put up new videos. Right, you can like it, thumbs up or thumbs down. Not too concerned about that. All right, and if you want to follow what I'm doing and help me pay for the tutors that I have, go to patreon.com. Over at patreon.com you can actually apply to have specific tutoring. I'm presently tutoring 3 students personally. One of them is in grade 12 and one of them is in grade 8 and the other one is in grade 6. Okay, good. There are also many more benefits that you can see on our official site. Okay, and guys, think positive. Math is great. Math is a lot of fun. Think positive. Think positive. Right, a whole lot of doors open up for you if you become good at math.